This is an introduction to section 4.9 where you will be learning how to graph quadratic inequalities and solve quadratic inequalities. The graphing part actually is not new. Like absolutely everything about graphing quadratic inequalities should be review. When you solve quadratic inequalities, it looks very much like graphing, so I want to make sure that you understand the difference between the two, and then the other videos will walk through specific examples. So what is the difference between graphing and solving quadratic inequalities? And the difference really is in the format of the equation. Okay, so here I have quadratic inequality in two variables, and here I have a quadratic inequality in one variable. So really that's going to be the difference. So note here you have two versus one variable. Well, if you have x's and y's and you have inequalities in the mix, you know that you're going to graph inequalities and shade. And that's it. So the shaded region, so for example, you might graph a parabola and you might have everything shaded on the inside. Okay, so anything in that shaded region is a solution to that quadratic inequality. You might have a system where you graph two parabolas, so then you would graph another one and shade that, and of course where their shadings intersect would be your solution to the system, right? So nothing really unfamiliar. Quadratic inequalities in one variable, note that the y is no longer, so you are hence solving that inequality for x values that make the situation true. So it's not a graphing problem, it's just solving for x. So if you solve this quadratic equation and you figure out that x equals 2 and 5, that's going to make it equal 0, but you want all the values to be greater than 0. So then you have to work around those numbers that you figured out to decide if it's going to be everything greater than those, everything less than those, everything in between them, etc., etc. So there's actually more work than just solving. So this is going to be kind of the new part here. Every once in a while, you might have to subtract c over. Of course, then it will look like this, getting everything set equal to 0. So two variables versus one variable. And of course, the directions, really, it'll probably say graph and solve. So it shouldn't be a huge deal. So here would be an example for graphing quadratic inequalities. So you might have one or two or even three, probably the most I'll give you is two, and you'll be asked to graph those on a graph and shade appropriately. Okay, so I actually have a video that's going to walk through all the steps and refreshing on graph, and this will actually be a great refresher for graphing because it's been a while. But a couple things I'm going to remind you about now that you might want to jot down in your notes in case you've forgotten is the difference between your inequalities and what that means in terms of how you make the parabola. So if it has an equal sign underneath it, you are going to make your parabola solid. If it does not have equal signs underneath it, then you are going to make your parabola dashed. Things you probably recall. Other things you might want to remind yourself about, of course, if you're getting things in standard form and you happen to divide by a negative, make sure you flip the inequality. And last but not least, if you're unsure where to shade, you should definitely test a point. So test a point for shading. And remember, if you test a point, usually 0, 0 is the easiest point, unless, of course, your graph goes right through the origin. And if it's true, you want to include that point in your shading. If it's false, you don't. None of this is new to you, however, but I will have a video on all the steps involved in graphing these inequalities. So you would you would graph the first one with a solid parabola. You would shade greater than. Then you would graph this parabola with a dashed, and you would shade appropriately. And then you would, where the two shadings intersect, make sure that that is nice and clear to anyone that's looking at your work. All right, this is what solving a quadratic inequality might look like. So note here, it doesn't say graph, it says solve. So first and foremost, you have a quadratic that's not quite in standard form. So you would subtract that 15 over to the other side. Okay, now, could you graph this? Yes, and you'd want to shade it, less than, but then you'd want to figure out what x values on that parabola are being shaded and write that as an inequality, which is kind of actually what we're going to be doing, because I always pull out just a little number line, but you really don't need to graph the entire parabola. So if I know here, and I'm going to do this one real quickly because I'll walk through several other examples later, but I could easily factor this down. Let's see here. So this would be plus minus, right? So if I factored that down, I think that works. Double check. 6 minus 5. Yes. So if I solved these right here, these factors, I would get x equals 5 halves and x equals -3. However, these are solutions to an equation, not an inequality. So if I put -3 in for all these x's, it's going to equal 0, but it's not going to be less than 0. So then I want to test some points in between these or on the outskirts of these, and I want to figure out if numbers that are greater than -3 will make this less than 0, or maybe it's numbers that are less than -3 that will make this less than 0. So it's really, it's a testing of points situation. And in the video on solving inequalities, I will take this further and do that for you, but it's going to be very different. So I'm just going to have you red flag this though, because this is typically where I see people stop. Okay, you are not done here. You actually have to take it further. And that is what I will do in the individual videos next.